Hello everyone, welcome to this second video on the topic oxidation number. In our previous video we have learned about the rules for calculation of oxidation number, and now we are going to apply the same to solve some of the examples. So I would request you to watch the first part of this video in order to actually understand and execute how the oxidation number is calculated for various molecules. If you have already watched it, then please proceed from here onwards. Here is a summary of all the rules that we have learned in our previous video. Now let us go ahead and apply them to see how do we calculate the oxidation number of a given atom in a molecule. Let us begin with this example Cr2O7 2-, where we have to calculate the oxidation state of chromium. Let us represent the unknown oxidation state of chromium as X, and from our earlier notes we can conclude that oxygen generally shows the oxidation state of -2. Okay, so these quantities represent oxidation state on one atom. Since there are two chromium atoms, so total oxidation state over chromium atom will be 2 times X. Similarly, total oxidation state over oxygen atom will be 7 times -2. On adding these two oxidation state over the total number of atoms, including both chromium and oxygen, it will be equal to the net charge on the molecule, which is -2. So we will get our equation as 2x plus 7 times -2 equals to -2. And from here we can solve for x and get the oxidation state of chromium atom. This will be equal to +6 in this case. Let us apply similar steps in another example and understand this rule better. Let us say we have to calculate the oxidation state of phosphorus in Na3PO4. Once again we will refer to the rules for calculation of oxidation state, from where we can note that alkali metals always show +1 oxidation state. So oxidation state of sodium will be +1. The unknown oxidation state will be represented by X, and again oxygen generally shows the oxidation state of -2. We will add the total oxidation state present on each of the atoms in the entire molecule. So there are 3 sodium atoms, so 3 times +1 plus oxidation state of phosphorus, that is equal to X, plus 4 times oxidation state of oxygen -2. 4 times -2. This will be equal to net charge present on this molecule, which is 0 in this case. So we have our equation in this form, and on solving for X we will get the oxidation state of phosphorus as +5. I hope you are getting familiar with this rule, so step ahead and try to solve the next example yourself. In this example we have to calculate the oxidation state of chlorine atom. The oxidation state of potassium will be again +1, since it is an alkali metal. It always show +1 oxidation state. For chlorine we will identify it as X, and oxygen again -2. So we will write the equation as 1, that is the oxidation state of potassium, 1 times +1 plus X, oxidation state of chlorine, plus 3 times -2, oxidation state of oxygen. This will be equal to 0, the net charge present on the molecule, and on solving for X we will get +5 as the value. So the oxidation state of chlorine is +5 here. Let us do some more practice based on the same rules and same steps. Okay, so now we have to calculate the oxidation state of oxygen on OF2. This is because fluorine is the most electronegative element and it has oxidation state of -1 all the time in all the molecules. Okay, so the oxidation state of oxygen will change from its general value -2 right here. So we will write it as X, which we have to find out, and oxidation state of fluorine is -1 all the time. So the equation is simple. X plus 2 times -1 will be equal to 0, and on solving for X we will get the oxidation state as +2. So please remember, the oxidation state of oxygen may be positive if it is linked or if it is combined with other more electronegative element, which is fluorine. Okay. Now let us calculate the oxidation state of chlorine in this ion ClO4 minus. We will again represent the oxidation state of chlorine as X. Oxidation state of oxygen is -2 in general, and so the equation will become X plus 4 times -2 will be equal to -1. Okay, net charge on the molecule or ion actually. Now solving for X, we will get +7. So oxidation state of chlorine is +7 here. So we can recall and revise few of the rules as well, and we can note new points as well. For example, we can see the oxidation state of chlorine in KClO3 is +5, and oxidation state of chlorine in ion ClO4 minus is +7. So it shows variable oxidation states, and we should make a note of such points and collect them together for our reference. Okay, so I highly encourage you to collect all such information in one place for your own reference. Now you can actually go ahead and solve all the examples yourself. However, again we are calculating the oxidation state, a few more examples so that you become entirely familiar with the rules and remember the oxidation state without consulting the chart of the oxidation state number. Okay, so here we will calculate the oxidation state of chromium. Let us assume it as X. Oxidation state of oxygen -2, and for chlorine halogens it is -1 generally. Now we will write the equation as X plus 2 times -2 plus 2 times -1, and it will be equal to 0. On solving for X, we will get +6, which is the oxidation state of chromium. Okay, so let us move on to our next example. Na2S2O3, we have to calculate the oxidation state of sulfur here. Since we know oxidation state of alkali metal as +1, let us assume the unknown oxidation state as X, and for oxygen it is -2. Now we can write the equation as 2 times +1 plus 2 times X plus 3 times -2 will be equal to 0, the net charge on the molecule. And on solving for X, we will get the oxidation state of sulfur to be equal to +2. In Na2O2, this is again a case where we will get the oxidation state of oxygen as something different from its general value. Because the oxidation state of alkali metal is fixed to be equal to +1, so we have to calculate the oxidation state of oxygen. that is, let us assume x. Then the equation becomes 2 times plus 1 plus 2 times x will be equal to 0. So the oxidation state here of oxygen will be minus 1. Okay. This is the peroxide ion. We have noted it down in our earlier notes as well. You can refer there to keep a track of different oxidation state of oxygen. Okay, so let us calculate the oxidation state of nitrogen here in HNO3, that is nitric acid. So the oxidation state of hydrogen is +1 when it is connected to non-metals. Oxidation state of nitrogen we will assume to be equal to X, and oxidation state of oxygen is -2. So our equation becomes +1 plus X plus 3 times -2 equals to 0. And on solving for X we will get +5. Okay, so the oxidation state of nitrogen is +5 here. Let us solve our final example, HPO4 minus. We have to calculate the oxidation state of phosphorus. Again, for hydrogen it will be +1. For phosphorus it will be X. For oxygen it will be -2. Now there is net charge -1 present in this ion. So on adding the oxidation state of each atom, we will equate it to -1. So +1 plus X plus 4 times -2 will be equal to -1, and this will be our equation. On solving it for X, we will get the oxidation state of phosphorus to be equal to +6. So I hope all these examples have given you enough confidence to calculate the oxidation state of an atom in various types of ions or molecules. You can go ahead and try to solve as many examples as you want from standard reference books. Thank you so much for watching this video, and in the upcoming video we will be learning about calculation of oxidation number from structures. Thank you once again. See you in the next video.